Okay, now we're up to this part. What we're trying to figure out is we're going to make the U and V, and then we're going to see how this new chart that we're going to focus on U and V, how this is going to transpire in the... I gotta get a new pen here. Doesn't work anymore. Good. Okay, so we're taking here the U and V. We're making him from 0 to 2, 2. That's what I did now. I've decided to focus on the UV rather than making the XY as a king. Here the XY is a king. You're making him from the 2, 2 square. Now I'm trying to figure out how this transforms in the V and the U and V. And that's hard work for me, because I'm interested more in the U and V now. So I'll make the U and V into a normal area, in 2 by 2, and see how this will interpret itself. So since we know x is equal to u plus v over 2, y is equal to u minus v over 2. So let's try to draw a graph and see. If it's 0.22, so x, this is going to be the x and y graph. And see how this translates into this. So x is u plus v, so it's 4 over 2 is 2. And y is 0. So x would be 2 and y would be 0. How about, so this point, I'm going to make it this. Made a star there. So that point translates 2, 2 translates into the bottom by the x. It's 2 is 0. Why? Because x is u plus v over 2. That's 2. That's 4 over 2 is 2. And y is u minus v over 2. That's 2 minus 2 is 0 over 2. This is the transformation of the x and the y. X is u plus v over 2. Y is u minus v over 2. How about the point here at the bottom? I'm making a circle here. The point where u is 0, u is 2, and v is 0. So x would be u plus v over 2. That's 2 plus 0, that's 1. And y would be u minus v. That's again, since v is 0, so x and y would both be 1. So 1, 1. This point here is 1, 1. Take a look. You see this circle here on the top chart, it was by 2, 0, and here it's by 1, 1. Again, I'm explaining why. How does that point land there? Because if u is 2 and v is 0, so you do transformation. U plus v, that's 2 plus 0 over 2 is 1. 2 minus 0 over 2 is again 1. So this circle gets transported from the point u, v, or 0 into the point of x, y of 1, 1. Let's travel to this point here on top. We'll just go to a few points to get an idea what's happening. Let's take this point here. There's going to be a triangle here. This triangle on top, we see that u is 0 and v is 2. 0, 2. So u plus v over 2 would be x. That's 2 over 2, that's 1. U minus v over 2 would be u is 0. 0 minus 2 is negative 1. So here x would be 1 and y would be negative 1. Again, u is in this case 0, v is 1, v is 2. So 0 plus 2 over 2 is 1, 0 minus 2 over 2 is negative 1. So this triangle here on top gets, u is 0 and v is 2, gets transported into this one at the bottom of the page, where x is 1 and y is negative 1. How about, just to finish the picture, we'll take a point, this is going to be this point here. I'm going to make a Star of David here. The point Star of David, u is 1 and v is 2. So again, u is 1 and v is 2. So u plus v would be 3 over 2. So x should be 1.5. Now y is u minus v, that's 1 minus 2, negative 1 over 2. That's negative a half. So here we got x is 1.5 and y is negative a half. Make a Star of David. X is 1.5 and y is negative a half. We'll take this downstairs here. We'll make something like a symbol. It's going to be an aleph, Hebrew letter aleph. Aleph is where u is 1 and v is 0. So it's 1, 0. So it's a half. X is a half, and y is also a half. Make here aleph. Now, all the areas where x and y let's say x and y are the same. So let's say x is 1 and y is 1. I'm sorry, u is 1 and y is 1. So it's 1, it's 2 over 2, 0. So basically it's taking over this line, it's taking over this line. It's taking over the line of this slanted line here, where x and y are the same, so it can span over from 2, and y will always be 0. X would run all the way from 2 to 0. I made a curve running there, a curve running there, and a curve running here, because these two curves coincide. Now here comes the funny thing, these curves coincide, but isn't that curve bigger than that? This spans from 2 to 0, and this goes in that diagonal, so it's bigger. So we must say some kind of measurement that probability of something being on that has the same probability of that curve. Here is where we need to use some calculus.